Hello my friends, welcome back. This is the third lecture of the soil mechanics series. In the last lecture, I talked about how to determine the water content of a soil sample experimentally using two methods. The first one was the oven drying method and the second one was the picnometer method. And in this lecture, I am going to talk about how to determine the specific gravity of soil solids experimentally. So, specific gravity of soil solids. Specific gravity of soil solid. It is generally represented by G or GS. Well, it is defined as the ratio of the weight of a given volume of soil solids to the weight of an equivalent volume of water, which means you have suppose you have this volume of soil solid. This one is soil solid. The weight of which is W1. Okay. Now you have an equivalent volume of water. This one is Vw, which is also equal to Vs. This one is water, the weight of which is W2. So Gs can be written as W1 by W2. Specific gravity of soil solids can also be defined as the ratio of the unit weight of soil solids to that of water. So it can be also written it can be written as unit weight of soil solids to the unit weight of water. The specific gravity of soil solids is a very important parameter, because if you want to determine other parameters like void ratio, unit weight of soil, degree of saturation, you need this parameter, this specific gravity of soil. So, well, it can be determined using picnometer method. So, suppose you have an empty picnometer, the weight of which is W1. Now take about 300 grams of oven dried soil. In the last lecture, I talked about the oven drying process. So, if you want to know about it, just go to the previous lecture and you will find it out. So, take about 300 grams of oven dried soil and put it in the picnometer and weigh it. Dry soil. And now add water into the picnometer after putting the dry soil and stir it properly. Okay, so now you have the solid portion over here and the rest is water. Suppose the weight of this is W3. So after weighing the picnometer, clear the contents and clean the picnometer and fill it up with water and weigh it. So now the picnometer is filled up with water and the weight of which is W4. So this one is figure 1, this one is figure 2, this one is figure 3, this one is figure 4. So now what is the weight of the soil solid? This one is the solid portion, that is so dry soil. So what is the weight of this portion? It is W2 minus W1. So weight of the soil solid is W2 minus W1. Now we need the weight of the equivalent volume of water, that is Vs. So weight of the equivalent volume of water. So how we will get the equivalent volume of water? Now see what? Now see, if we subtract figure 1 from figure 4, that is 4 minus 1, we will get the weight of the total volume of water filled in the that is inside the picnometer. Okay, so let it be A. Now if we subtract 2 from 3, that is we are subtracting the solid portion, we will get the weight of this volume of water. Am I right? 3 minus, we will get the weight of this volume of water. So let it be B. Now if we subtract B from A, we will get the weight of the equivalent volume of water. Am I right? So now, so specific gravity of soil solids can be written as weight of these soil solids divided by A minus B, that is W4 minus W1 minus W3 minus W2. This one is a this, so this is the formula for determining the specific gravity of soil solids using picnometer method. Well, specific gravity of soil solids is generally reported as at 27 degrees centigrade. So suppose if your test temperature is T degree centigrade, then we can write Gs at 27 degrees centigrade multiplied by specific gravity of water at 27 degrees centigrade equals to Gs at the test temperature, that is the T degree centigrade, multiplied by specific gravity of water at T degree centigrade. From this relationship we can express the specific gravity of soil solids at 27 degrees centigrade. So that is all for today. We will meet in the next section. Thank you.